Okay, let's do this. Part 3. So yeah, back to the stream. I don't know that I have enough. I should probably set aside more time today for non-streaming related activities like tidying the shop and video editing, and already did some more errands this morning. But yeah, I actually stayed up really late last night babysitting the 3D printer. But the part that I ended up with is pretty cool, and so I wanted to do another stream and share what we got and try it out on camera. So looks like we're live on Twitch, twitch.tv/scanlime. Seems like YouTube's coming up too. The encoder there is a little more sluggish, but we are also live at Scanlime-in-Progress on YouTube. And we've got live.diode.zone/scanlime also live. Welcome back. So I don't know where my cat is. Usually that camera in the corner is him. Oh, I hear the birds outside. So it's been rainy and cold, and the outdoors is currently full of crows making noises that my cats like. So. And you might see some of the box mess here. There's just so much stuff here. I've been making a lot of progress on getting it sorted into these little plastic bins now, but the actual plastic bins themselves are completely disorganized right now. So it's like sort of a fine-grained structure, but then a macro-scale mess at this point. Oh, there's Took. Can I put this on automatic tracking? Will we have good luck with that? Warming up the shop with some GPU-assisted tracking here. Oh, and then he walks off the bottom, but here he is. Hey, boy. So yeah, just for a little context, this is a weird little side project. I've been finding myself really depressed by a lot of technology stuff, and so this, while it is a technology project, because that's like all I know how to do, it kind of connects to something that I've been finding some interest in lately, which is I have another pet besides my cat now. I've got these little critters, these little crustaceans, these little isopods. They're about a centimeter long or so. I've got a box full of like decaying leaves in the closet that all my isopods hang out in. And I thought it was interesting to try to share that with all of you. So of course I've been streaming it with cameras and stuff. It isn't on Twitch or YouTube, and I think I might keep it that way. Like we could pretty easily set up another account for it, I guess. But you know, we've got Diode Zone, and it seems like a decent way to just have some Diode Zone exclusive content, my 24/7 isopod stream. I don't know, to the extent that any of that matters. This is a weird, like, directly top-down kind of view. Doesn't kind of getting gimbal lock here, trying to find Tuco. Not like my gimbal is locked, but I guess the polar coordinate or spherical coordinate phenomenon here. I'm going to try not to worry too much about him, because he doesn't seem to be in a demanding mood right now. So yeah, I've been trying various different camera setups for my buggos in the closet. This is what we've got right now. I just swapped out the USB hub for this, so I'm hoping it's a little more reliable. I was using a non-powered USB hub, which was not so great sometimes. So yeah, here's my little critters. Sorry if you're squeamish about bugs. I think these guys are cool. I won't have them on like all the time, full screen or whatever, but sometimes I'll have like a little thumbnail. But yeah, I mean, there are a lot of different common names for these, like woodlice or roly-polies or pill bugs. Oh, just a second. I got a surprise text from a friend, and I should probably respond. Might have even less time to stream than I thought today. Well, let's see. Bones. Right? Robbie says should have used quaternions, jokingly. Yeah, right. I do actually plan to use quaternions for a lot of things in the robot, but yeah, like the physical gimbal kind of does need Euler angles, like the way it's built. I don't know how you'd make a quaternion physical gimbal. Also, the camera's overexposed right now. I always have to fuss with the camera exposure when it kind of transitions between day and night here, but maybe it's easier right now to fuss with the light than to go into the dialog box. Dugo, off this desk. Dugo is not allowed on this desk, and I need you to notice that. Dugo, off this desk. Okay. Although I kind of, it's too dark to photograph actually. I need to put that light back. Sorry, failed experiment. How is everyone else besides, you know, the usual? I mean, the usual's fine too. We can talk about the usual. Two goes over here. Tuco, you're not allowed on this desk, actually. Tuco, I know the winch is cool. Like, gosh, it's easier to drive the winch with two hands. Tuco, off the desk, honey. Tuco, you're so cute, but you're not allowed here. You can hang out on any other surface pretty much. Yeah, that surface is cool. Thanks. Oh, my cat. Okay, exposure. Sorry. Oh yeah, Jarrett says that we should just make it a 4D gimbal. Yeah, that works. Project it into 3D space. Yeah, it's the exoskeletal things again. Yeah, that is true. You can call them that. I have a bunch of affectionate names for them, apparently. But yeah, the exoskeletons are nice. They look really great close up, too. Just like really shiny and beautiful. Oh man, those two are riding each other again right now. It's getting a little saucy for this stream, maybe. There are two of them in particular that have just been like really into it on this lately. But yeah, you know, it'll be nice to eventually have baby isopods. I don't know how long it'll take for that. It could be like 6 months or so. It could be sooner. That's my hot water machine for making coffee. Apparently I have water for coffee if I want it, but let's drive over. It looks like Tuco's chilling out on the heat pad now. Oh gosh. Oh gosh. That's me not having collision avoidance sensors and not paying attention. Oops. Oh, that was probably my friend texting me again. Okay. Yeah, I thought I might have last minute thing I needed to do with a friend soon, but maybe I don't. More time to stream and or organize the shop and or edit videos and or get bossed around by my cat. So the usual for me at least. Anyway, yeah, sorry for all the stalling and fussing with my hardware. You're probably all anxious to see this 3D print that I've been keeping from you. So this is the thing that we designed on the last couple streams. It's for this microscope that I've been using this for my streams for a long time actually. It's not currently hooked up because it's disassembled, I actually got a second one for my live streams because I like this model enough that it seems useful to just have one in my isopod enclosure and one for streaming. And it's a pretty good deal, I think. Like, it's a really nice picture, and it seems pretty hackable, both physically and software-wise. You know, it's a nice sensor. The optics seem good. All the mechanical parts are kind of cheap and flimsy, but not like overly so. Just like, you know, just barely. I mean, not. I don't know. It actually kind of varies because like the plastic enclosure for the microscope is actually pretty nicely designed. Like, it fits together very nicely. Very tight tolerances for what it is, but it's just not really that well thought out, I think, necessarily. Like, it kind of wastes a lot of space and makes the whole microscope a little hard to use in tight situations, which is kind of why I'm here designing this microscope enclosure. But then other parts of it are fine. Like, the optics are pretty good. The zoom assembly doesn't seem like it's especially long-lasting. Like, mine's feeling a little crunchy at this point. It's possibly because I've abused this microscope a little bit and used it in dirty environments, like places where there were like paint and particles and stuff splattering all over to film a music video. So there's that. So, you know, this one's seen better days, I guess, but even still, like, it's all like plastic gears that don't have a huge amount of lifespan to them inherently. So there might be some room for improvement there, but it's a really good basic microscope for the money, and at least for me, searching for it online, I find it between like $100 and $130 or so. So the idea behind this is, so this is Autodesk Fusion 360, which, you know, has its ups and downs, but it's at least a really powerful program that is available to use for free if you're a hobbyist or academic or, you know, anybody who's not a big company, basically. And this is a combination of some mock-ups of parts. Let me actually clear the screen a little bit. There's too much other stuff going on. Actually, I really should be using this layout anyway. And this just has more room, so that's fine. Yeah, so this is a combination of some mock-ups of pieces that I designed. Wow, my Space Mouse just got way more sensitive for some reason, and I don't know why. It's kind of throwing me off. It looks like it's set to the default. I don't know. Maybe I'm imagining things. I think the Fusion 360 might just be... Like, I think Fusion 360 does some scaling based on what sort of zoom it thinks you're working at, and I think that might be off. Or maybe I'm just misunderstanding what's going on. Anyway, I think I can still drive it. It's just feeling a little twitchy. And I don't want to actually change my Space Mouse settings, because I think I like them the way they were. That's fine. I just have to be really delicate. So, let's simplify these. So this is the PCB layout. We actually drew this based on this scan. So I tried just doing this with the calipers, and that got me, you know, like 60% of the way there, but not nearly enough, because these curves over here were just too confusing. I was trying to measure like the distance between this edge and this edge, but there was a combination of factors where these are actually both circle, like arcs, like pieces of a circle. The center of the arc actually changes. I think that one and that one have the same center, but then this one has a different center. And then on the actual circuit board, there are these fillets, which I've ignored in the model, but they make the measuring a little harder. So all of that was really complicated. And a bunch of folks in the comments were like, why are you making this hard? You can just round it all off, make it boxy and whatever. But like, having a good layout for that part of the circuit board is exactly what allowed me to make this case as small as it is, which I'm pretty happy with. So I think it was worth it. It was just annoying. And so I actually made this with a combination of this flatbed scan. And again, I want to emphasize, flatbed scanners are great for this, but if you're going to buy or search for a scanner that you can use for photographing circuit boards, two things you absolutely need to look for. You need to find one that doesn't have a contact image sensor, but has like a CMOS or CCD sensor. So those typically are thicker, like 3 or 4 inches or more, rather than like 1 or 2 inches or thinner. Those tend to have like a camera sensor, but like one line, typically a bit bigger than a camera sensor, but smaller than the page. And then a bunch of usually pretty okay optics to zoom that out to the page width. And so those actually have a pretty decent depth of field, but they do have parallax error. So you end up with more distortion the further you get from the intended image plane. You can at least make the parallax error symmetric and minimize it if you keep the circuit board close to the center of the minor axis. So if you have like a legal size, like 8.5 by 14 or whatever scanner like a lot of folks have here, or actually maybe the scanner is a bit bigger than that, but like a page size scanner, if you put the circuit board in the center of the short axis of that page, then you'll get a better image. So those two things combined will give you pretty good board scans without having to do any fussing. So I didn't have to do any like undistortion transforms or any of that. I just used scale and rotate in Photoshop to line up these layers. I didn't even need to do the layer alignment to get the board outline. This was just nice because we might want to reverse engineer some of this later. And I'll store it. I'll put all this stuff on GitHub soon. It isn't yet, but I'll make a little repo with the mechanical stuff for this. So yeah, this is actually pretty cool. You can see I started out just with this attached to the plane and then built the outline around it, combined a bunch of these points were just kind of placed ad hoc, like by looking at the, I would work at a particular grid, like 0.1 millimeters or something, and then just choose the grid intersection that fully encompassed the scan of the board. That's how some of these points came about. Like I think these edges came about that way, and some of these edges over here. But the most critical dimensions, I always want to measure those with a caliper, because I just don't trust anything else. So all the screw sizes and the distances between screws, I had to do all those with calipers, despite them still being really annoying to measure, because there are just so few flat surfaces. So I actually ended up getting a bunch of the screw dimensions by measuring the plastic enclosure that this originally came with, because that actually had some internal surfaces that were flat that I could use as references. So yeah, that was a lot of annoyance there. Oh yeah, and for setting scale, I did not put a ruler down because I wanted to measure, because like that only works if you assume that all the optics are perfect and there's no parallax. And there's still significant parallax error, like not so much that I had to do an undistortion, but enough that if I did a measurement like that didn't account for parallax error, I would expect to be like maybe a millimeter off or something, which I wouldn't be happy with. So what did I do? I used the existing image, but I tried to find some reference points that were really far apart. And so I think I ended up using some of these vertical flats, like maybe these and these. I think I used this horizontal, which is about 70 millimeters. So a printed grid helps only insofar as, like, the problem here is that the board isn't flat, right? The flatbed scanner is already actually really accurate at scanning a flat surface. It's designed for that. The parallax error I'm getting is because the board is not sitting on the image plane of the scanner, it's sitting above it. So honestly, the easiest and most foolproof way of correcting for that is to desolder everything from the board and then scan it. But that's a destructive process, and I didn't want to destroy one of these cameras necessarily. And yeah, like if you did put a grid, like, I mean, if you just like laid a paper with a grid on top of the board, that would give you some idea. If you did think there was more, optical distortion in the scanner that you needed to correct rather than just the parallax error, then a grid like on a transparency might be useful. But yeah, I haven't personally done any of that. I've just worked based on features in the actual scanned object and then measure those features with calipers. That's always been my favorite approach. Because then you're sure that you're actually getting the actual plane of the object, not a plane that's above or below it. I just like that, and it seems straightforward. If you have something to measure with calipers. That was just hard because this board has so few good measurement surfaces. So anyway, made a mock-up of this board, which is this. Made a very simple mock-up of the optics assembly. And the actual sensor, the image sensor, man, I might have to restart Fusion 360 because this control sensitivity thing is actually really bothering me. How long are you going to take to save my file? Getting cloudy over here. Oh gosh, I have hot water and I could make more coffee. I mean, I was up super late last night babysitting the 3D printer. I had one failed print because of, so the print that I started on the stream failed because it failed to adhere and then it warped and then it caused some missed steps. So yeah, the root cause there was a combination of needing to clean and re-glue stick the bed and being slightly too far away in Z height. I have a somewhat old printer at this point. I don't know, it's still great. I really like my printer, but it's like 5 years old at this point, and it's missing a couple of features that are like really standard on 3D printers now, like automatic bed leveling and a heated bed, which I miss sometimes. And so at some point I'll do a mod, because both of those are fairly easy to add. But yeah, it doesn't have auto bed leveling. I get it pretty well dialed in, but then when I turn off the 3D printer and it cools down, then it, it's just like the whole enclosure of the printer kind of warms and cools a little bit just based on the heat the electronics and stuff generate, and I find that changes the accuracy a bit. Yeah, right, I agree, the splash screens are strange. I like, I don't know, the concept of the splash screens, but the particular art always just seems like something I want to lampoon in some way. I find myself really sensitive to noises sometimes, and there's one that I couldn't identify, but I think it's like a fan kind of far away. You're all set with the latest update. Thank you, kinda. I didn't extremely ask for that. Alright, so this is the very simple mock-up of the optics assembly. The image sensor board is kind of here-ish, where I'm drawing with my mouse. And then there's a whole tube of optics that point out further this way. This model really only tries to capture this edge and the interior and exterior diameters and the kind of minimum diameter of these screws. There's that. And this is the most complicated piece, really, this box bottom. I can hide the optics for a sec. So this tries to hold the PCB snugly. And I went through a couple of iterations of these support posts. The first simple support post was just like a cylinder straight up with a little bit of a chamfer for relief at the bottom. They just broke right off for a couple of reasons. They weren't actually deep enough for the screws I was using, but they also just didn't have enough plastic supporting them. And I can do much better by actually making them part of the same loop of plastic that goes through this outer wall as it's printing that layer. That makes it much stronger. So joining it to the outer wall just makes it much stronger as a 3D print and also just as a physical object. And then I extended this also so it supports the area under what was a peg on the original design, but I didn't want to try to 3D print such a thin object because that just wouldn't be strong. So I just left it as an underneath kind of support. And these are the holes that just kind of miraculously worked great for the self-tapping screws that I have. So I hope we have good luck with the rest, I guess. That's the spot for an SD card. Oh, that's the SD card. That's for a brightness knob. And then I did my best to make these sort of hinged assemblies so that I could have like tactile button covers for the buttons on the circuit board without making a completely separate piece of plastic, which would be another approach. And that's actually the approach the original case uses. The original case has a hinged insert that then pokes through the original case. That's just, more assembly, and it seemed like I wanted to try this approach and just make the case a little simpler if I could. So then I added these vents, and I added these sort of angled covers to prevent as much light as I could from, traveling from outside to the back of the sensor area, because the board that the sensor is on is not entirely opaque. I might also add some opaque stuff of some sort to the back of the board. There's a few things I could use here for that. But it seemed like this was just a good thing to have either in addition to that or just as a feature for people who use this case and don't think to cover the board. Then this will just be some extra light baffling for folks like that. And I might be that person. I might be the person who just doesn't add any additional covering. We'll see how well this works. And then these actually should fit the connectors pretty snugly, like that. This is mini USB for power and data, but I mostly use it for power. And then mini HDMI for video out. And then this peg here is a pretty important mechanical anchor for the board, but it also serves as a spot for the two halves of the case to anchor to each other, which is important. And then I'm pretty proud of this lip here. This actually works pretty well, I think. This is what actually holds in the other half of the case. So if we turn on the top half, it's got this little interface where there's an angled ridge that just barely makes contact. There's no clearance there, so really there's like a little bit of a spring fit where it snugly just like tightens in there. So there's this little zero clearance inclined surface that holds it together all around the edge, 180 degrees. So the idea is that you can kind of slide this in that ridge and then secure this in with a screw. And then everything else just kind of fits in around the other features. There are additional things we could add. One constraint that I've been setting for myself is I want both of these to print easily without supports. And that means that I've chosen this bottom to be my flat printable edge. So I can't easily just jut down from here, like to cover gaps like that, for example. If I wanted to cover this gap, I would need to modify the features in the bottom, which, for here it's pretty trivial, but like here, for example, that's less clear what I could do here. I could come out there and cover this gap, but above the SD card, there's not really anything I can do. So yeah, I could tweak this a little bit, but all the major things seem to work. The thing I have not tried so far, I have not tried actually fitting the PC board in here or trying out the buttons, so I'm going to do that on camera right now. Oh gosh, I'm sorry, camera. Oof. I don't think I damaged it. I shouldn't do that. Just like elbowed the gimbal just then. Here. That's one nice thing about having the gimbal on like a pendulum arm is that it just kind of starts it swinging. It doesn't really take a lot of impact just there, I think, I hope. Well, it's found Tuco. Let's see if we can be mindful. That's the other problem. The LED ring on there is still broken. I need to fix the LED ring, and without the lights on, it's even easier to not notice. I should use some of that hot water and make some tea or coffee before I dig into this, actually. I know I'm sorry to keep you all waiting, but I also feel like with all this talking, my voice is already giving out, and I do actually need the next part to be something that is, worth editing into a video later. So yeah, the usual problem where, glossy black PLA is hard to photograph, but we'll do our best. So yeah, this is 2 pieces. And I'm just so happy with this fit. Let me switch this to manual. We're not very servo AF today. So to get this out, you can kind of sorry, I'm like trying to demonstrate it, but also like really struggling to remember where this focus plane is. Anyway, I'm having a hard time demonstrating that fit. I'll was like trying to show you the texture on this thing and not the texture on my hands and the work surface and my nails that need a little bit of work. So yeah, I mean, it pretty much looks like it does in the CAD model, and this fit is pretty snug. Like, one of the things I was most worried about is supporting this optics mount relative to the rest of the case pretty well. And I mean, you're hearing it flex a little at this side because there's no screw in there, but that side is pretty solid. So we'll see how it is with the board and the screw in there, but. Having a little trouble finding that way to click it in there while also keeping it in focus. Sorry. Let me try to do this a little more just to have some footage that's good. And this is right off the printer. I didn't do any cleanup, so there's still a little bit of stringiness, but it's pretty good. Getting kind of annoyed on Twitter earlier today because I was posting pictures of this and someone was like, oh, it looks like you got under extrusion everywhere, and I'm like, what are you talking about? This looks great. So I don't know if we were just miscommunicating or if they're like, you know, secretly like working for Z Corp or something and they're used to like 10 micron resolution printers. But like, I'm pretty happy with this finish. And it was a pretty fast print too, I think. It was like 2 or 3 hours for both the pieces. Yeah, biggest unknown right now is I don't know if these buttons will actually do the job. I don't know if they have enough clearance here. Like, they don't push in especially far before they hit the lid. Might be enough, might not be. So let's put this down and try to keep the focus constant and put the circuit board in. Maybe with my anti-static bracelet. Also try mounting the optics assembly, although, yeah, highest risk thing I think right now is the button fit, so I want to address that. Yeah, like, I mean, you know, obviously you could always tweak 3D printers. There's always stuff to nitpick, but I'm pretty happy with how this is coming out just straight off the printer. Alright, so here's the previous version. The button's already broken off. Alright, and this is actually screwed in because the self-tappers worked out beautifully here. I'm extremely paranoid about losing the screws for this right now. It just seems like the kind of thing I would do. I've got to put them back in the correct location. These bins are going to become my life now. The isopods, the soldering, everything just in the little plastic bins. Different ones, clearly labeled. I'm trying not to mix the bins that have contained lead stuff with other kinds of uses, you know. Aw, Russ lent their 3D printer to a friend who's enjoying it a lot more. Yeah, that's real. 3D printing does take a lot of fussing. You know, it kind of has a lot of potential, but you get out what you put in to a lot of extent, but maybe maybe less than what you put in sometimes. But I think it's actually really powerful, and I did seriously contemplate doing this design without 3D printing, and then just thought that the 3D printing would actually make it easier, or at least make it, you know, it would give me a clear path to producing something that I would be fairly sure that I would like, I think is what I'm trying to say. Whereas I could hack something together that would probably work. And sometimes I would like that. You know, I've got a lot of stuff like that. A lot of these isopod camera prototypes have been just like hot glue and popsicle stick prototypes, which is sometimes exactly what I want. But sometimes what I want is a nice form-fitting 3D printed case, which is what I got here. I guess I can leave the SD card in there too. I feel like I'll just lose it if I take it out right now. I don't know if I can actually do better than ServoAF right now. Oh, I reinstalled AWS. I've got a new lightweight version of it. The anti-wobble sandbag. I think these screws are somewhere between M1.5 and M2. The holes I'm using are like 1.8 millimeters. So they're probably supposed to be like M2 self-tappers. We can inspect the damage in the posts too after I take this out. The screws are also just a little oversized for the holes in the circuit board even. They dig into the fiberglass a small bit. Not bad. Looks about like it did when I put this in. None of these are wildly off-center, really. Like within 0.5 millimeter or so. Ha 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 ha! Russ says they think it's about a decade since they bought their first 3D printer and they're not sure they're that useful. I mean, I get that you're into complaining about them right now. I'm just saying that, like, I've found them really useful for, like, specific things that I don't know how I would have done otherwise, so I'm not really sure, like, where has your failure of imagination been so far? Like, they're certainly not a panacea, but there's a lot of cool things you can do with them. Yeah, these were too fused together there and too flimsy right there, so they just broke off. All right, let's try the next one. So this one, by contrast, this is the new version. I've not tried to put any of these screws in yet. I think these all move separately. And they seem to flex enough, maybe. Let's see if it works. Stay focused. Ah, so far so good. Oh, that feels great. The feel actually varies very slightly, I think because of the SMT placement, actually. If you look at the board, this switch is slightly closer to the edge of the circuit board than that switch. And this one actually feels like it's like a little more preloaded, like it's a little more ready to snap, whereas this one you have to push it further. But they all feel like they're in a usable part of their range there. Oh yeah, Renato's asking about the digital microscope that I'm using. That's what this is actually. It's and it's labeled on the other side, but it's sold as a generic 1080p HDMI microscope by a few different brands. I think the actual model number of the circuit board is um016. But that's what we're working on right now. And I was thinking about getting a different kind, but I'm pretty happy with this one. Okay, well, I don't know if that'll keep working once I put this top piece on. Let's find out. Oops. There's a little more stuff to fit around now. Feels a little tight around the USB mini jack. I don't know if it's too tight, but it's snug there. Maybe that's fine. Focus. I think the PLA here is actually confusing the focus with all these shinies. Oh yeah, coffee time. You're right. I was gonna get some coffee, which is a silly thing to do at this time of day, but I'm a silly person. Oh, that's pretty good. So I am actually lamenting the lack of a kind of Z-axis support for this part of the case. You can feel it click, which is unsettling. Maybe it'll be better with the screw in, but I feel like this is actually already pretty solid, whereas this part of the case wants to creak a little. So that could use improvement. Okay, do the buttons work? Oh, the buttons don't work. Well, these buttons work, because they're slightly closer to the edge. These don't work. Okay, I do need to tweak this. I should give the buttons definitely more clearance on the top part. I might also just adjust the clearance in general, because I'm a little nervous about how close this is to clicking. I don't want it to be quite that preloaded. So I might nudge the clearance very slightly. Which I could do by changing the depth of the button plunger in my model, because that's actually what that's based on. Yeah, and then maybe a little more space around the USB, just so that that has less chance of not fitting on someone else's model or for my future prints. I think this is actually causing it to kind of like twist slightly when I force it in. So I think there is a little interference around the USB connector, but it's really close to being dead on. I didn't put the screws in for the circuit board. Pretty sure they'll work. I didn't change that part of the design. Is there actually a button? Because that feels... What is going on there? Is there a button in this design I didn't miss, or is my plastic just extremely clicky? Am I going to have to spudger apart my own design? It is actually pretty tight around the USB port. Well, it's not just around the USB port, actually, around the HDMI. Oh! Yeah, this... Sorry, I was a little off frame. This back edge of the HDMI port is actually interfering with the top just a tiny bit, which is having the effect of wedging this into there. So it's actually keeping it secure, but it's putting a lot more pressure on the board than I would want, so I don't actually want that. Yeah, I want to see if this screw fits. Let's try that. And then, yeah, I should make some coffee, like I said. This is why I never go to sleep. Except, I mean, I do. It's... Some people might be familiar with this, but it's like sometimes really, really easy to focus, and sometimes just absolutely impossible. Sometimes you just can't stop working on something, but sometimes you just can't start. Oh, that beautiful fit. Except for all the ways in which it kind of sucks. Is there actually a button in there? screw hole is great. I've got to try the cables in here. Yeah, some of the buttons work. And like, it's kind of hard to test fit this whole thing because I actually have to route the cables, but I can test fit the optics assembly against the top part of the case more easily. Yeah, that's better. Is there a button that I missed? Like, it really felt like I was clicking a tactile switch, but I don't see any vertically oriented buttons on the side of the board. Certainly wouldn't be on the other side, right? I think that was just something flexing in a really clicky way. Let me see if I can identify what that was. But maybe I'll try this first. So the way this fits, those go through there. This is a little too big. It's actually not an insignificant amount too big. Well, yeah, it looks like it's only about 0.3 millimeters or so, but it's consistent enough that I just can't fit it even slightly in. So yeah, that doesn't actually fit. But that's where it would fit if this were working. Have I found any problems in the bottom half yet then? I mean, I might want to change the preload in the buttons, I guess. I said that. Someone suggested last time putting labels on the buttons. Yeah, that might be a nice idea. I feel like we have so little space, but maybe we could have at least some way to tell them apart. I don't know. But anyway, I'm going to make that pot of coffee I talked about. I'm going to leave you here with a little collage while I do that. Yeah, everyone's like, I should make coffee. Yes, I'll be right back. I guess I'll leave the mic on since the crows are making interesting noises. Maybe you like them. Tuco is still chilling out. Good job, cat. Got my warm beverage. That's cool. Comment in YouTube, Digital Radio Hacker says that Tuco is representing them at 2 p.m. this afternoon through the magic of dance. The heat mat is there for theatrical effect. I didn't use one. That is relatable. Oh man, I got a weighted blanket recently, and it is the best thing. Just have to put that out there. It's not heated, but it is weighted, and I find that pretty satisfying. I think the whole thing weighs like 25 pounds. You're just like, it just feels like someone's just like laying on top of you, or like you're putting a heavy piece of furniture on top of you or something. I used to actually do that when I needed to chill out sometimes. Just like wedge myself under the bed, and it was pretty cool. Maybe that was TMI. Okay, let's try to fix all these bugs before we forget about them, or maybe we could make a list, but maybe we can just fix them. There is it for this stream. Every stream there's a comment in Twitch chat asking if I check Twitch chat. Yeah. It's just funny because it always happens before someone has even tried to communicate. Like, I mean, not always, but I feel like usually people ask if I even check Twitch chat before they've even like tested whether I check Twitch chat. So I don't know, I just find it funny at this point. It's like a weird thing that humans do sometimes. Let's try to give these more clearance. How did this come about? Oh, I might just try to talk through what I'm doing slightly more, but maybe slightly less sometimes. I don't know. Right now I feel like just mentioning that the way I'm actually locating some of this is by looking at, so if I select a part that involves some feature that I care about, it'll highlight all the features that were involved in the creation of that part down here. And I didn't know this for the longest time, but since I noticed it, or since someone pointed it out, I forget which, it's been a real time saver. So it gives you this little hash mark around any feature that resulted in the creation or modification of whatever you selected, so like a face or an edge or a point or something. So in this case, this whole face was the result of this extrude, and then things get a bit weird, because here actually this is the creation of a component. So actually that kind of like loses the link a little bit, and there was actually a sketch somewhat before here that I moved into the component. But I can look in this vicinity and probably find what I'm looking for. So it's not that, but I think it's the one. I might get a little closer if I select an edge that was specifically cut right there, but I might not. Can I not do this with an edge? Oh yeah, I can. I think it just took a sec. So yeah, the same thing, that extrude. If I look at this extrude, oh, edit profile sketch. That's actually helpful. So I can select this, then the corresponding extrude, edit profile sketch, and then it'll find, like, where am I? I'm in top outline. Cool. So it went right there. I could also find it by name, but it's like easier to find it by geometry sometimes, because that actually matches what I have here. I don't have to also remember the parallel organization system that I have in here. Maybe that just means my organization system sucks. I'm still like extremely new at trying to keep documents organized in this tool. I feel like there's a lot to learn, both in how to create something at all in Fusion 360 and in how to represent it in a way that doesn't become a mess easily. That's just a fact of parametric CAD in general. Like, you'd see that with SolidWorks or with, like, I guess, SolveSpace or FreeCAD. I try using those for projects occasionally. It's really not the same category of tool as this, but sometimes you can do things with them. I think I just want to double those clearances. Mostly, actually, not because of inaccuracies in my 3D printing, but inaccuracies in the placement of parts on this board. It just seems like the compound of the clearance I need for 3D printing, 3D printed parts, and the clearances I need for the kind of like slightly wobbly surface mount placement on this board. I just need a little more room. 0.4. I think just doubling this will be enough. I don't think I need to go higher. Yeah, and I might want to add little support shelves for some of the thin parts, like around here, around here. But that's like an enhancement. I want to fix the bugs first. So that should fix the fit on top. Let's do the button fixes. So that's back in the bottom component. So this button spring relief is really the main mechanical feature that defines how the buttons feel. Yeah, that side view is a little more useful here. Oh yeah, the weighted blankets are usually full of, they're like a quilted construction, and each of the pockets is usually filled with little weighted beads. The one that I got, I think the beads are glass, which seems interesting. Like it's easy to wash, I guess, and heavier than most plastics. 'Cause it's a pretty nice one. It's like 25 pounds. It's so cozy. Anyway. I have to reorganize this a little bit because I just made this attached to the button face when I know I said I could just make the plunger longer, but I think that's a slightly dirty solution. I think I want to do it a little differently. I think I just want to remove these constraints. Yeah. And then I can add a clearance. Oh gosh, those aren't parallel. Okay, so how much variation do I think that surface mount placement had? I want to go with like 0.2. That might be too much. I dragged it to kind of where I wanted it, and actually 0.15 is pretty much right, I think. Let's try that. Didn't I have another circle down there? Oh, no, I didn't, because that's just like, that's just an overhang. I don't think I need, right, because that's not really a stressy point right there. I'm not going to worry about that. I think this is all fine. Okay, so that fixes one problem where, that should fix the problem where there is a little bit too much preload on the most extreme of the buttons. So now let's go back to the top and carve out a little more space. This edge, I want it. Oh, dang. That's also kind of what sets the limit for this shoulder right now. It's okay though, I think it's still enough. Where did that come from? I thought I offset these, but they don't look like offsets. Oh, they're broken. They used to be offsets, and now they're broken dependencies. Is that what I'm reading? I don't know why this isn't yellow then. What if I go back there? Yeah, that's just unconstrained. It's funny though, actually I got myself a bit more clearance just by reducing, like that same change I just made also cut this a bit. You know, honestly, if this cutout is causing me so much of a problem, I could just truncate the buttons and have that edge be more flat, maybe. Oop, drop the whole thing. Yeah, I don't know. The amount of extra space I need is so small. What are these two different lines? That's the PCB edge. Can I fit a whole millimeter? What? This is an unconstrained mess. I should really redo these as outline or as offsets. Oh, what else is on this sketch? Oh, there's too much else on this sketch. Yeah, that's like one benefit to keeping the sketch as simple is if you need to redo one because it becomes a giant mess, then you can just delete it all. And you're less likely to confuse the solver. Oh. So hard to actually connect with people doing stuff that feels, you know, like stuff I can contribute to or relate with or really anything. It's like hard to find connections with people. It's like I just got invited to this event that I like really wanted to go to in some ways, but just also seemed like something that wouldn't work. Like just I feel like this a lot with like parties and conferences and stuff like this now, where there's like some part of this opportunity which feels, oh, like somebody like me should like this is what I need, but it also feels really inaccessible. Like the whole way of interacting with people is never going to be productive for me because that's just not how I can meet people. I don't need it to come this far that way. does it look like if I don't try to be fancy, if I just make this larger but same, basically? I think it still picked the right outline. That's what I was trying to do still. Okay. Ooh. Yeah, I can't have that. That's what I meant. I don't know why that, I mean, I guess that, of course, that dependency got lost, but I don't know why it didn't get flagged as an error down here. It's weird. Okay. What does this look like? I want to look at this a little more. I think that probably fixes the button problem. So yeah, that's my piece. That's the optics assembly. That's the shelf it's sitting on. It's narrow. I'm about to give it a bit more room because I'm about to refine the dimensions of this edge. It also sits on this edge, which is slightly convenient. Oh, what's going on there? Oh, that looks fine. It's just a little weird looking in there without any shading. But I think that's the right shape. That would be more obvious in section view. Yeah, restarting, I didn't actually mention this, but restarting Fusion 360 totally fixed the sensitivity problem I was having on the Space Mouse, because it feels completely fine now. Yeah, it was like maybe like 5 or 10x too sensitive or something like that. Like it was just using the wrong multiplier. Okay, what is the actual diameter? And where did I mess this up? It's 36 on the outside. I also find it really hard to concentrate when I'm waiting on something that involves even the tiniest of social interactions. Like, I'm waiting on a UPS pickup today. I have no idea when it's going to be, or if it's even going to happen. And when it happens, I'll just have to deal with, like, a tiny social interaction that brings me some amount of anxiety at some random time. And it's, like, just kind of harder to concentrate with that looming than I would like, which is frustrating. It's a silly thing to complain about, but it's on my mind. I must have just typed the wrong number there. This said it's absolutely not 34. That is nowhere near correct. Am I just measuring this wrong? Because like that assumes 1 millimeter thick walls basically, which I think this is more like 2 millimeters. Yeah. So yeah, it was actually interfering a lot more than I even thought it was. It looked like it was a fraction of a millimeter, but it's more like an entire millimeter on each side. So I'm actually getting something more like, at most, if I kind of like really dig the calipers into the plastic very slightly, I can get maybe like 32.2 in certain places. But it seems like this is kind of hovering around an average of 32. Just 32 bang on. So, and do I have the clearances? I think the clearances are in the other sketch, so this should be the actual dimensions of the optical assembly. If I remember right, so 32. But let's check the clearances. That's a lot different. I think the screw depth is still correct. This is actually countersunk. It looks weird here, but in reality there's a big countersink. I should maybe even just try to approximate that with a chamfer just so that I know, so that it's less confusing to look at. It won't be extremely correct, but this piece is just a mock-up. I'm sure there's a correct way to do this, but I'm just doing what I know and moving on because it's a mock-up. Yeah, sure. That's probably pretty close, actually. I think I do have clearance there, but let's just make sure. This. Yeah, this dependency did not break, which is good. We didn't add or remove any edges, we just kind of moved things around. And we've got 0.2 clearance, which I think is about right. Okay. Okay, I think that's everything I had to change. So, fixing bugs I knew about. So fixes the interference over here. I think we've got enough room for the buttons to move more freely now. And this should actually fit. That enhancement I was talking about adding was to reduce, because like right now, the case clicks a little bit. I want to debug the clicky feeling, because I don't want it to feel that way. I think that's just some flexing on these thin pieces that I need to support. I need to support them better. Oh, man. Yeah. That's what's going on. The clicking that sounds just like a tactile switch is really just 3D prints scraping against each other, and you're hearing the layer lines interlocking and scraping past each other. But what's happening is, even if I kind of pretend the screw is here and hold this tight, even if I do that, I can press right there and make it click. But you can see what happens maybe if you're looking closely, that this edge right there and this edge right there are scraping past each other. So I could fix that in multiple ways. I could make them further apart so they don't actually scrape, just increase that gap a little bit. That is part of the gap that just goes all around the boundary between case halves. But the reason it's being forced right up against that edge kind of strongly is that that's kind of what's, like, a combination of that and this screw and really any other edges, that's going to be what immediately retains this into this semicircular groove. So I don't really want to give up that interlocking because that helps the case be sturdy. But if I could additionally restrain this up and down in that vicinity, that would help. So, I don't know, like some kind of snap or shelf or something. I like the clicky buttons. Oh yeah, the audio volume, I did actually turn the levels down a little bit relative to what I had it at for a while, because I think some of the mics at least were a little peaky at times on the stream. Check, 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 check. Yeah, I mean, it's not peaking, but I could see maybe turning up the compressor a little bit. Did I turn off the compressor? I think I just want to turn up that mixer channel if, you know. I could turn up the gain. I don't know. Does anyone else have feelings about the mixer? I can turn it up a little bit here. Is that better? I'm going to lose this when I start the next stream unless I actually save this file. But let me know if it's better and I'll save these as new defaults. Yeah, it's weird the way packages and social anxiety interact, huh? It's like the tiniest social interaction, but it's still like a human showing up at a time that's completely out of your control, you know, like waiting for Comcast or something, but this like micro amount of it. It feels like this could use more clearance on the bottom side for the SD card. Or maybe that's my imagination. Oh, I think there's just some gunk in the socket. Like, I thought that was interference, but I think the socket has actually just got some debris in it. I'm just thinking about what to do with this. I really like this edge. I just can't do that all the way around because then I'd never get it together. Yeah, maybe we just want to try to engineer a little snap closure into the edge right there. And right there. Because that's doing the same thing. Which are kind of the places you would choose, I guess, like right there and right there. That's a good place for a little extra hold together. Because, I mean, this is serviceable. I could use this enclosure, but I would like it to feel better. I mean, the buttons are kind of a problem. I would need to kludge that together, but, you know, and then the optical. So, I mean, this obviously has problems, but the current CAD model, I mean, I could use that, but I would like some more support. Oh man, look at how close that comes to the circuit board. It's interesting. I think there's enough room for the wiring, but it's more of a tight fit than the old case for sure. It'll make the whole thing pretty small. Like the whole microscope is going to be much smaller now. It'll just be, like, imagine this was mounted on that piece, you know, at this level. That's the whole microscope, the HDMI output. Yeah, exactly. Michael has succinctly summarized this project. It's a right-angle repackaging of the microscope that I have, which is normally cylindrical. So normally this would have been like that in the original case, but now I'm putting it like that, so it can fit in my isopod box. I mean, I might actually put my other microscope in one of these boxes also, because it just keeps it a little more out of the way for the stream here too. You know, it's not a bad box in general, I think. I could also label the buttons. I'm still not sure I have enough space to do that meaningfully though. And if I can't label them well, I might as well, like, I don't know, just like assume that either they're going to be unlabeled or we find a way to put like a paper label on label, or a paper label on later. Label, 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 label. Oh yeah, that's a good question. Digital Radio Hacker asks if, because the microscope is HDMI, they're wondering if the video output is pretty real time. And they're after something that's useful for soldering or inspection. Yeah, that's basically exactly why I have this. The output is pretty real time. It probably stores 1 frame of video, so it's probably lagging behind by like 30 milliseconds. But it's definitely fast enough to solder with if you've got any kind of halfway decent monitor. I just use it with like a pretty generic, like probably was like $100 new, like 1080p monitor, and it looks fine. Yeah, it's 60 frames per second. I think the output is natively 1080i actually. There are some hacks to switch it to progressive scan, and in fact, I think there are different firmware revisions out there, so maybe the one you get is different. I'll certainly let folks know what I find when I get another one of these in the mail, but I think it's a pretty good basic microscope. It goes by various brand names, but I think the actual model number is um016. Alright, well, snaps. There are a lot of different ways to do this. We really should do this in section view. I think my coffee's ready. By the way, isn't this cat great? I think we just need to appreciate how great this cat is. Oh, and Satan Sandwiches, who was back here from last night, is still trying to figure out what was living in the leaf litter. Maybe you've already heard this because I've mentioned it a couple times, but they are isopods. The stream for them, if you go to live.diode.zone /isopod or isopod, or if you just go to live.diode.zone, you'll see a link to it. And there's some text in the bottom left corner that actually tells you what specific kind of critter they are. They are Armadillidium maculatum, otherwise known as zebra pillbugs. Yeah, I've only seen some people actually list this as a um016 microscope, and I only recently noticed this on the circuit board written down there. It's like tiny in the silk screen on the other side from what we were just looking at. But yeah, at least one of the Amazon listings I saw for it actually does list it as a um016 in the description. But it's also sold under various brand names. I think the brand of the one that I just ordered was like Mustcam or something like that. But yeah, they look pretty generic. The actual microscope doesn't have a brand name on the outside. And it looks like the kind of thing that could easily have been assembled from fairly generic parts that people had been, using for other purposes also. You know, it's like hard to tell how much of the design is specific to this microscope and how much of it is shared with other products. So that might be how it's so inexpensive, is that they might just like be borrowing parts from other things. Ooh, yeah, and I've heard good things about the Andon star microscopes. I just wasn't really ready to drop 300 bucks on another tool for work right now, when it seemed like I could get something that was basically useful for a lot less than that. But yeah, those seem nice. I've contemplated getting a nicer microscope, but I have an optical microscope. It's a binocular um016, which I really like. It's just hard to share with all of you. So I might try, you know, I've tried 3D printing DSLR adapters for it, but I might try another approach. Like, I have some better cameras here, like the camera that I use for Tuco Flyer. The one you're looking at right now, if you're looking at the stream, is a 1080p SDI camera, which is originally designed as like a security camera, but it actually has a pretty great sensor and decent onboard processing, and sends out uncompressed video, which I can then capture and compress myself at higher quality. So I really like that. But yeah, it's interesting actually, if you look at the internals of inexpensive cameras, you'll find a lot of standardized parts. Like the lenses are often M12 standard metric threads. It's really just like you took an M12 bolt, hollowed out the center, and put a lens in the center, and like that's pretty much every webcam lens is one of those. So actually, basically the next project I want to get to here for the isopods is to finish that C920 webcam mod we were doing earlier. I got a couple of parts I was missing and a couple of lenses we could try to do a proper version of that. But a lot of those mounts are also standardized. A lot of them I think use 20mm diameter holes around the sensor, and then that 12mm thread in the center, and you can get replacement mounts made of metal, for example. I found this 3D print on Thingiverse actually that was pretty much exactly what I needed. It was an M12 to C90 adapter, so I printed a couple of those. And they also listed this vitamin, which was an M12 locking ring, which they were using for the threads. And the same store that had those also had some interesting lenses, and so that's what I got. And we'll take a look at that on stream soon. Yeah, let me show you the stream really quickly in case you missed that earlier. So live.diode.zone/isopod. Oh, I think my camera's frozen. Yeah, so this is a problem I've been having, which I really need to debug. It's just not quite the very top of the to-do list right now, but yeah, I keep having to reset the USB grabber. I'll be right back. So I've got this USB 3 video grabber, which I honestly haven't really used it a ton recently. Like, I pulled it out of my box of like hardware that I was using for my live streaming at some point, but currently have taken out of service for some reason or another. And I don't remember why I wasn't using that one for the live streams. The video you're seeing right now is actually going through a USB 3 HDMI grabber, but it's a different brand than the one I have in the isopod box. And I think I might have been having this problem before. I should have put some notes on it, but I didn't because I'm not that organized. But so it might actually be that that's somebody next door moving stuff. I think that it's possible that even if it isn't like a design problem with the grabber, that maybe I just have a unit that has like a bad solder joint on the power supply, or like a flaky USB connector or something of that nature. So it's a hard thing to debug though, because it's a very intermittent problem. Sometimes it happens like after an hour, sometimes it happens after a couple days. You know, it's like that kind of frequency. So very annoying to debug. Nothing relevant in the kernel logs or anything like that. Like, it just stops streaming, and then you have to restart the device for it to come back. It's very possible that it's a software bug in either the UVC driver or OBS. So like I could try completely different software setups, but I've seen this on different computers and different XHCI cards, so I've at least ruled that out. So yeah, kind of a pain. And there are other cameras we can set up that aren't HDMI, so like the C920, that's a USB camera, but I don't have the C920 in there right now because like we need to do some modification work on the C920 to get it, because it's built into a lid for a different size bin right now because I moved the isopods to a different size bin. So all the cameras I was using on the previous bins need to be modified for the current setup. I don't think I'm planning on putting the cameras into the lid itself anymore. My current setup, the lid actually has these kind of mesh tubes going into it that I can lead wires and stuff into and then close off with clothespins or clamps. So that gives me a way to provide a controlled amount of ventilation to the isopods to keep pests like flies and stuff out, and to run wires in when I need to and put some hardware in there if I want. So right now there's like a camcorder kind of hanging out in there, but I think my plan is to keep that pretty much intact and not cut additional big holes in the lid, but maybe to cut some small screw holes and mount some like plates under the lid, which then hold cameras. So I'm going to try to go in that direction, but that requires a little bit more CAD work. That's interesting. Yeah, Digital Radio Hacker is not seeing much about the um016. They're seeing something called the um12C, but those seem to have optics that keep the device close to the subject. Yeah, I can't speak to the um12C. I don't know anything about that. What I will say is that on this one, the um016, the working distance varies a lot depending on magnification. At low magnification, there's tons of working distance, like 4 or 5 inches. At high magnification, you pretty much have the lens right up against the subject. But the highest magnifications are usually not what I'm using for soldering. So for soldering, I actually find the working distance in this microscope is fine. Like, it's closer to that long end of like 3 or 4 inches. So I find the working distance pretty good. Although that is why I cut off some of the front of the microscope, was to increase the working distance. It had some unnecessary plastic, so I just cut off the plastic, and that increased the working distance by like another inch. So yeah, but I don't know if the um12C is related at all, or if it's better or worse or whatever. I can't speak to it. These little critters seem happy. He's munching on these leaves that I boiled for him a few days ago. Oh yeah, actually somebody just asked what the isopods eat. Yeah, they eat leaves mostly, but I also feed them this high protein gel stuff called bug burger sometimes. They eat like pretty much anything that's dead, basically. So you can give them vegetable scraps. They eat like other dead insects. They eat their own molting exoskeletons. They eat, you know, lizard poop. But I think they mostly like to eat leaves. They tend to live in leaf litter on the ground, and they hang out under leaves and munch on them, or under wood. That's why they're also called wood lice. They eat wood and leaves and tree parts and dead plants and whatever. Rotting stuff. I like that they eat trash. Oh, there's the section view. Okay, so anyway, just like where we are right now, I think I fixed the actual problems. I'm just trying to enhance it so that it feels more sturdy around these edges. Looking at how to do that. So yeah, I mean, I could do this with kind of a little like triangular shaped bump. Because that's a nice shape that's easy to 3D print. You just kind of overhang out a little bit, then back in, and then do something similar on here. One constraint here is that I can't go below this line on the top half, because that's where my print bed is. If I go below there, then I have to support the entire thing and makes the whole print a lot worse. So I could make the locking structure above this whole thing, or just entirely within this wall, depending on what I think I can get away with. This is 2 millimeters, right? One point 1.3 millimeters. This little peg in between the two sockets is also not the strongest thing. Also, anything that goes out past the right edge of this is going to interfere with the board as I'm installing the board, so that's something to keep in mind. I mean, it seems like the first thing to do is have a little shelf here that comes out and supports that base, because there's not much downside except for the interference with the PC board there. And I think we can get away with almost none of that. And then actually I wonder if we could just do that same kind of angled trick that we used to hold in that side, just a lot less severe, so that we could kind of snap it in on this side. So not add a separate snap inside this edge, but angle this edge itself so that that edge plus the shelf under it act as the snap. I don't know if that makes sense in words, but I think I know what to draw now. Oh, I do want this to be in the bottom. Do I? I think so. I just made the sketch up here, which is not useful. Okay, and that can be pretty, I can go below where that slot is if it needs to. I like the way 0.6 millimeters sounds. That's the bottom edge of the top lid right there. And now we've got an angle here. This is based on what kind of overhang I'm willing to print. 60 seems pretty alright there. like not that much of an overhang, but I also kind of want this to be strong. What is that attached to now? Nothing. Cool. That wants to be on that line. Okay, that's the shelf. And this is going to control kind of how snappy it is, like this and the angle. Another similar thing here, I don't want this to come to a point right at the top. Let's come down by maybe a little over a layer. Another 60-degree angle, why not? So this needs to be, it needs to be easier to get this over the snap than to get it completely past the shelf. So 0.8 is actually way too big here. That's too small. That should just be a millimeter. I'm not thrilled about that interference, but I think we can wiggle the board around it. Also, I don't want that coming to a point either. I neglected that earlier. So the whole point of this is that it should be hard for this to come out. And like putting it in, it doesn't matter if that requires this edge to kind of bend outward slightly to get this on. But then once it's in, it should fit snugly, which means probably having small areas of contact with zero clearance and then a little bit of clearance elsewhere. So this would be something to add to the bottom, then this would be something to subtract from the top. You could also round that edge a little bit, but I don't think we need to. That would just make the top more likely to warp as it's printing. Oh, that's 0.6 and 1. I don't know if we need to do this sketch again elsewhere, if there's a way we can reuse these for the other similar snaps. Probably we can reuse them somehow. Oh, I attached that to the wrong vertical. This is like asking a lot from a piece that isn't the strongest to begin with. But I don't know, these 2mm walls aren't that bad. I think I can make both of these a lot smaller. I don't know. What would the cutout look like? This is not enough information to disambiguate these two pieces. They both have a cut in that area, and they both start with the same few characters. And just hide the other one, though. that's what we've got in section view now. So no interference, but we've got this whole thing with kind of zero clearance that supports on the bottom and kind of wedges in on the top. So then I think I just need to it's like tempting to put the other side's snap on the same one just so that I can use equality constraints to make them the same shape. I'll just make the sketch plural, edge snaps instead of snap. Oh yeah, that's a good question about, on Twitch there's a question about what the resolution of the printer is. There isn't really a straightforward answer to that because you could talk about that in different ways, like, you know, like what's the thinnest thing you can print, what's the most accurate sort of positioning you can do, what's the most accurate control you have over the specific amount of plastic that's coming out. How much accuracy do you have in controlling like where the edge of the bead of plastic is as you print it? So this is why people fuss with their printing settings endlessly and print calibration objects and whatever. I'm sure that the actual like positioning accuracy of the stepper motors is way smaller than is actually useful. Like on the I don't know. I would just be like guessing numbers, but you know it's like a very small fraction of a millimeter with the micro stepping. But what really tends to limit the accuracy you can design parts to expect is more like how much, like the actual surface roughness you see, the like unevenness, the lines, that's like, you're seeing the inaccuracy, and the reasons for the inaccuracy come down to a lot of different sources, down to the actual slicing and turning things into layers, down to the kind of uncertainty in you know, like the difference between what your printer is actually squeezing out of the nozzle and what your calibration and your slicer software thinks it's squeezing out of the nozzle, things like that. But also just like layer to layer variations in like the temperature and how much your belts are wobbling or whatever. It's like people spend a lot of time dialing this in. I tend to expect parts to fit within about 1/4 millimeter on my printer, but I kind of change that up or down depending on how tight of a fit I'm looking for. Haven't measured a calibration cube recently. I should probably do that. Yeah, there are definitely some digital microscopes out there with a really terrible working distance. Some of the little USB microscopes, especially, you have to be like right next to the lens. But yeah, that's one of the things I liked about this one. It didn't seem like it had that problem. It seemed like it, at least if you were not trying to go for the maximum magnification, the working distance was pretty good. I think that just comes down to the, like, the focal length of the lenses they're using. The working distance seems like it's similar to the length of the optics tube when it's at full extension. Yeah, when the optics tube is fully extended, actually, it comes out past the edge of this container. Normally it wouldn't have, but because I trimmed the plastic a bit, it pokes a bit. But when you're at lower magnifications, it doesn't do that. Okay, I'm on that same sketch. I want the other side snap to be over here. Oh, this one's simpler anyway, because I already have a shelf. So, assuming I already have a shelf, let's look at that. Ooh, look at that more clearly. wanted to see what's going on. I want to see what's in the middle there. There. Yeah, right there. So there's the lid, there's the PC board, there's the edge. We've already got a shelf. So yeah, same snap. This was measured from the edge of the bottom half of the case. So this measurement includes the gap clearance. And the position of this plane is not useful. I'm going to have to project it before I use it. Man, there's really just one dimension here I'm ending up transferring. It's not especially helpful. Yeah, it goes over, down, and then back. Cool. That seems printable. Yeah, that's the projected line we had on the other side. Seemed right. Okay, we're still in the bottom half. Let's make a projected version of that over here. I just want to continue it into the surface and just kind of disappear into that edge. It doesn't have like a clear plane to stop at like on the other side. So I can do that. What is that? That is a geometry mess. Okay, I could avoid that by extending this profile somewhat arbitrarily into this wall, I think. Yeah, that worked. Cool. My intuition for appeasing the Boolean onion. Okay, and then we can trim that out of the top. Just labeling one of these sketches. Oh, I want to do this with the top as my current component. Oh, same problem for that. You want the cutting object to not have any edges that are ambiguous like that, to be like clearly on one side or the other. If you're going to have any question about numerical precision. Okay, let's look at that in section view. So that snaps in on there and uses the existing shelf. And all of that seems printable. So one more thing to look into would be this little interaction. That could use a support shelf. That's also, unfortunately, a place where the circuit board needs to come straight through the top to fit in there. And there's very little wiggle room in that particular area because this is really close to this post. And the post fits snugly on the circuit board. So I have to kind of keep this edge clear. So I don't think I can modify the bottom to include a normal shelf there. So maybe I reverse these. I have this come out on top and then sit there, which at least, I think that makes it stronger. It doesn't matter that much either way. Could do the same kind of angled thing here, but that puts more stress on this peg piece. I could just leave that alone. How bad is that in my current prototype? It doesn't feel extremely professional. I think I'm right that that's the weak point in the design right now. Because it's susceptible to being pressed on, kind of. It flexes. It's held right nearby by that post, but it's a small piece. How are our bugs doing? Walking. Munching on leaves. There's not a lot on this side. So they're actually in a kind of large enclosure right now, and I just have the camera pointed at this one area because a lot of them were hanging out there, but I think a lot of them moved on to other locations. Critter. Oh, that's all rain noises. accurate simulation of rain is happening outside. Oh. So this PCB is a clearance mess at that edge because they were really trying hard to get the connectors close, and they were probably having some clearance problems with their case too. So right next to the connectors there's some through-hole pads that are a little iffy, but in the very middle of that area there's actually enough room I could add just like a little post that comes up. I think that might be the approach I take. Caliperize this a little. So yeah, like that solder pad, kind of not a lot of clearance, but in the middle there's a clear spot. Like, what is that kind of shaped like? It feels like a millimeter would fit there comfortably. An entire millimeter. That's enough, I think. We don't even have to use the whole millimeter. Like, I don't want to be greedy. So box bottom. This one will be shaped a little different. I actually want to make this sketch. I want this to be in the bottom component, but can I use the bottom surface of the top cover as a reference point or reference plane? Looks like it. I don't know if I'll regret that later. And then how much of that millimeter? 0.8. That's like most of the millimeter. Midpoint. Oh, I got a perpendicular constraint. Okay. Didn't actually want that. I should have made that a construction line. Yeah, so there's, I think, a little more clearance than my model was actually showing for the PC board right here. So I think that'll fit. I don't have to use quite that much, though. Let's do 0.7. And then how wide do I actually want that to be? Maybe I just want these to be equal. Yeah, that looks better. So that's also an improvement even on its own, but it's also setting us up to add a snap right there, just like we had before. I don't know if I can... I'm just going to have to specify the dimensions again. If I was really trying to do this especially clean, I'd probably make variables for stuff like this. I was trying to just do it with sketch constraints. So, yeah, 60 degrees. So the relevant dimensions, which I'm just going to copy because I'm getting lazy about it at this point. 60 degrees, 0.2 millimeters, and 0.6 millimeters. I was going to select a plane, but I think I already had a plane selected. Okay. So we got one snap-friendly surface there, another there, another over there. This is a somewhat different, like, much more intense lock down over here all around 180 degrees. And then so yeah, you can see here there's a gap for clearance in portions of the perimeter, but then where the snaps are, it comes together tightly. So all around there, right there, right there, and right there. So the intent here is to keep the case from making squishy noises when you mash on it, basically. In every other respect, it would have been fine without these, but it makes the case feel flimsy when it squishes when you mash on it. So this supports the top and then also holds it down simultaneously. Same there. Over there. About ready to print this. What's wrong with my section view? Okay. And then this area still seems fine. Not amazing, but fine. And we did change that. Okay. Bump some version numbers and slice some G-code. Oh. All the settings were fine from before. Slice. Still estimates about 2 hours to print both halves. So much rain noises. I like that extra bump. That's going to make that a lot stronger. Okay. Printer looks good to go. I do believe this is a good time to start my coffee. Yeah, if we end up with some time to kill waiting for this print, the next thing I wanted to try to get done here was to get my C920 fisheye camera working for this too. And in fact, in some ways that's more urgent because, as you've noticed, maybe I'm having these HDMI capture card crashes. And if I'm going to work on that, I need to have a camera on my isopods that is not HDMI, so the fisheye camera, or the C920, seems like a great idea for that. Ah, it sounds so rainy. How's everyone else doing? Well, Tuco's sleeping. The isopod's reading leaves. At least the one that I can see right now. Oh, nice. In chair with cat. That sounds good. Oh man, I just realized food is a thing. It's really rainy, but it might be nice to go outside anyway and get some pizza later. I could make pizza here, but I could also go outside. You know, choices. Oh, this isopod is so cute. I don't know, is anybody else watching the stream? I think they're fun. I think some people... I actually got one request on Mastodon. Somebody wanted to know if I could add a content warning for the isopods, which, like on PeerTube, which was a weird request to get given that PeerTube doesn't really support that yet. It's like, well, I'd love to mark the content up in ways that are helpful for you, but you're not really asking for me to do a thing. You're asking for a whole new feature to exist right now. Sorry. And I didn't think they were especially, like, I mean, I know some people don't like bugs, but the thumbnails really were just a pile of leaves, and the title clearly indicated what it was. I wasn't just trying to ambush people into clicking on my leaves to get surprised by bugs. So, I don't know. Oh yeah, that's cool. Reckless in Twitch chat says that they're lurking and they haven't put the effort into do Gitter yet. I mean, that's fine. I don't like expect people to do Gitter. It's just there because a lot of us find it convenient. But, you know, I do try to keep up with all the chat systems to the extent that I can. As usual, it's kind of hard to tell if the printer is really dialed in without looking at it in person because this camera angle is, you know, it's never perfect for everything. The side view that you're seeing looks great for time lapses, but is a little challenging for debugging the printer. And actually, I wonder if I can make that other view bigger. That little view is actually a pretty high-res camera. Oops. Oh my gosh, the layering here is all wrong. I think the chat wants to be on top. I'm gonna have all the frame dropping in OBS, sorry. Oh, actually both of these cameras are scaled a little bit. That's weird. Is this not actually a 1080p camera? I'm just resetting the transform to pixel accurate, and yeah, I thought this was a 1080p camera, but maybe it's giving me a slightly lower res stream right now. Anyway, the thing I wanted to actually try was to make this one bigger. This view is maybe less interesting for when I'm in the closet, but like we can see the printer more easily. All right, well maybe I will look at the print in person briefly, and then I'll bring the C920 over here and we can take stock of what's going on with that. seems fine. The Z height is maybe a little bit on the close side, so it's doing the thing where it squishes it into the platform a bit, but I think it's still within the limits where it'll work fine. I might have to keep more of an eye on it than usual, though. Oh no, I'm getting rated. That's a good thing, though, right? I don't entirely know how Twitch works, to be honest. But hello, if people are here. So, I was trying to kind of finish up this microscope re-encasement project here, which was taking up space on my desk and covering it in tiny screws. But the other thing I want to do is to get this camera fixed up a little bit. This is the camera I was using for my isopods. It is a modified Logitech C920 webcam with a fisheye lens and a really terrible improvised lens mount right now. So I want to take this apart and put a better lens mount on it, because that will help with the focus. It was a little bit soft before. And this ring light is, these are white LEDs, which I'm running at really low current, and it makes a nice, like, kind of dim illumination for the bugs. It's nice. Oh, and then this is a camera too. This one is the tiny endoscope, borescope style camera that I was using to get more of a bug's eye view. And that just happened to be in the same box. I'll take the duct tape off. Your desk is already covered in parts, probably. Okay, I think we're done with these prototypes. This aside. Okay, so switching gears slightly, we've got 3D printed lens mounts, have some lens things, this box also just has a bunch of other parts that I took out of the C920, which we might need some of them back. Like the screws might be useful. Oh, I've got a lens cap for the lens too, which I might put on before I mess with this too much. Oh, Reckless is wondering about the cameras. They say I have a lot of cameras. Yeah, I mean, like, what do you mean in specific? Just like in general? I mean, I guess I do have a lot of cameras. I don't think that I have quite as many cameras as I need a lot of the time still. It's like some people have, you know, like a big stash of studio gear. I feel like I mostly just have like one good DSLR, which doesn't do 4K video, so maybe I'll want to upgrade it at some point. But then just like a bunch of other cameras that I find, like, yeah, some of them are webcams, some of them are just like cheap sensor modules that I find on eBay with a lens. Some of them are like security camera style cameras. Like the Tuco Flyer. So like if you're wanting an ID of the cameras, like this one up here, this is a DSLR. It gives you kind of low quality video out of the HDMI. So what you're seeing here is more of like a viewfinder view than like an actual video feed. The actual video is recorded on SD cards where I edit it later. So when you see these shots in editing, they look a lot nicer than they do here. And then that is a C920. It's unmodified. It's just doing its thing. This one is, actually someone suggested before that they wanted like a hand mirror or something to see these cameras, and I think I can actually do that for some of these. dusty mirror. So, this mirror is filthy. It's not extremely much cleaner, but... So yeah, that's what you got here. That is a T5i. It's got a different European model number, like 600D or something. But yeah, it's good. I like this camera. The main shortcoming I have with it is that it doesn't have clean HDMI out, as I'm sure all of you are aware and keep telling me about. It also doesn't do 4K video, which is a thing I might want, but does a pretty good job of what it does do. This is a teleprompter adapter that I use sometimes. It's flange. And then this is a 3D printed focus lever. And then 2 cam. That's me. So yeah, that's the flying camera. It's on a bunch of winches. So that goes to pulleys on 4 corners of the room. Normally those are LEDs, but the LEDs need some work right now. Oh yeah, and that's a laser. It's got some laser distance sensors too. And then this one. It's like a regular C920 with some duct tape to shield it from the studio lights. So, actually I've got a bigger. So yeah, and the C920 is pretty good. Like, it doesn't give you uncompressed video. The best it can do is like pretty alright H.264 or high bitrate MJPEG of some sort. I forget what bitrate it goes up to. Whereas this one gives you uncompressed video. I'm getting it with a PCI capture card. And yeah, like a lot of cameras don't have clean HDMI out. A lot of the times it's done intentionally in order to have the cameras like sellable as still cameras rather than video cameras. For like tax reasons, basically. So yeah, already redacted the personal info here so you can see what this actually is. So these locking rings, these are vitamins that were recommended by this 3D print that I printed. I got these 2 different lenses. This is the focal length, f-stop. This megapixel rating threw me for a loop at first, because like, okay, really, come on, a lens, who needs a megapixel rating for a lens? But like, it actually does mean something. It's kind of a shorthand figure for the optical clarity you would expect from a lens. And there's like a rigorous definition of that. I have no idea whether these folks are adhering to that definition, but like that's what they're really talking about is this lens ground sufficiently clear that if you put a 5 megapixel sensor in it, you would actually be getting that many pixels of useful resolution. And then the actual resolution you get also depends on what size sensor you're talking about. This 5 megapixel rating is at a particular sensor size. It's not listed here, but yeah, on the description, the sensor size was also listed, which doesn't match my sensor size, of course. So I then have to like calculate, well, okay, with this particular sensor, how much of the lens am I using? What is the actual equivalent resolution? So I'm not an expert with optics or anything, but I tried my best to get some lenses that would be okay with this camera. we'll see how well they work. This looks like one of the lenses and a mount. Yeah, I also got some mounts. I got 2 of these lens mounts. Not for this project, really. I don't think they'll work for the C90, but just because I wanted some lens mounts around. They are 18mm, which is smaller than the most common 20mm, because I think I already have a few of those. But I think the C90 was something like 16mm. I don't even know if it was a round number. I think it was maybe like 16 and a half or something. Cool. So that's one of the wide-angle lenses, and here's another wide-angle lens. And this is going to be the mounts. Gosh, yeah, post-stream pizza might be nice. I'm gonna have to try to find some pizza through the rain. Then, yeah, this is the mount, which I may or may not be using for this project. Comes with screws, which is handy. I thought I ordered 2 of these. They're not stacked or anything, right? I ordered 2 of these. I don't see the second one. Maybe it fell out. Oh, I've also thought about putting a thermal camera in there. The bugs are not really giving off heat, but the evaporation might be interesting to watch. I might have misplaced it, but it also seems quite possible they gave me fewer lens mounts than I ordered. I mean, that was like $1 or something, but I'm slightly annoyed. Yeah, I don't think I misplaced it. Alright, that's my 3D print. That's weird, they gave me plenty of screws too, and only 1 lens mount. I don't know what's up with that. And 2 different sizes of screw? I feel like these are just extra options for the screws, and maybe they just should have given me another one of these bags, but I don't know. Anyway, this is the 3D printed part. I was going to show this on Thingiverse, because I like to show you what I'm actually printing. This one. Yeah, M12 lens mount for the C920 by Matthew LAI in 2014. I don't know why they printed this in white. It seems like you would want this to be as opaque as possible, which is why I printed mine in black. But yeah, yeah, this I think is already sized for self-tapping screws, and it doesn't have 3D printed M12 threads because that would be a little extreme, but it has room for one of these locking rings glued in top. That. Yeah, it's also possible they printed one in white just to make a good photograph. It's quite possible. That's a good point. Because mine is not going to be as easy to photograph. That's my print. Basically the same setting as I'm using for this thing I'm printing right now. And it's got, you know, at least some holes there. Oh, neat. Reckless Jumper says that their ideal lens setup would be more complicated because they want a filter wheel. Yeah, that sounds nice though. So this is circular but with a flat on one side. So, or maybe a flat on two sides. It's a slippery little critter. It's hard to tell if it's going to fit, actually. It doesn't feel a lot like it is going to fit. It doesn't seem like a small difference either. Like that's it fitting partially, but then how much interference is there on this side? Oh, maybe I can get it in. It's just, I think it's right. I think it's just a tight fit. I might use the vise. The Thingiverse page said to glue it in, but maybe this will hold it. I mean, for testing maybe, I think I would actually want to glue it in though, permanently. Seems like epoxy or CA glue would do it. Seems pretty flat. Definitely flatter than I was getting it before with hot glue. Speaking of hot glue. Alright. Let's just put all the M12 lens stuff in a bag. This would have been a decent advertisement for their lenses if they gave me all the products I ordered. Well, we'll see how well the lenses work. Okay. Gosh, sorry the chair is getting all creaky. I thought I was using the quiet chair. I think first step is I take the endoscope camera off of this because it's just in the way. I was using this metal mesh for ventilation, which is really not optimal, but it was what I had. The choices were just this or cheesecloth, and I didn't quite have enough cheesecloth, or I think actually the cheesecloth was more precious to me at the time than this metal mesh. I've got a roll of fiberglass screen at this point though, which is much better. That's what I've been using. The metal mesh is kind of pointy. I'm gonna try not to touch it because I got cut up pretty badly on it once already. Alright, and this is basically just a very small USB camera and a really little like cylindrical package with a wire that has a stiff conductor in it. It was part of that Wi-Fi endoscope, but it was basically a scam. Like, it was claiming to be a 1080p camera, but it had software that worked on a 1080p phone, which is I think what they were really trying to sell you. And the camera was at best 720p, but only if you reduce the frame rate. So to get 30 FIPS or like 25 or whatever, then it kind of only goes up to 320 by, or no, 640 by 480. And it's kind of noisy at that. So, I don't know, it's an interesting camera. Like, the size and the perspective are hard to beat, but it's not better than like, I think this is just a completely garden variety VGA size sensor in a endoscope, USB endoscope camera, which you can find a lot of these for like, I don't know, like $15 or something. And I think the folks who are charging more for like the Wi-Fi versions that claim to be high resolution, that's all done in software and isn't actually real. Just scaling. So yeah, if you were to just cut this wire, you'd see normal USB, which I've spliced into this plug, and then the yellow wire is the anode for the LEDs. So I had a breadboard with some resistors that I was using to power the LEDs. I think I'm going to trim this wire once I figure out how to mount this in the new isopod box. I do want to put this camera back in the isopod box. It's not perfect, but it's pretty nice. I've actually got to bundle this up or it'll spring everywhere because the wire is springy like that. Yeah, right. Comment from Twitch that, yeah, I wish product descriptions didn't lie 75% of the time. Right? And there's so little consequence for it when they do. That's why, like, when I do, I've been, like, cranky about it lately, and when I see a product that's, like, blatantly unsafe or, like, lying about something, I will definitely write it a bad review. But I don't know if anybody cares, because like there are always so many clueless reviews that are like, oh man, I used it for 10 seconds and it wasn't obviously terrible, so 5 stars. Okay, so then there's the ring light. I might want to take that off too. My thinking about this is that, so like this was pretty cool having this in lid. It meant that with the small isopod box, I could just see kind of the whole thing, and it was a nice perspective. I think with the bigger isopod box, I kind of want this on a stiff wire that I can position to get different views inside. And I like the ring light, but I think maybe what I want to do is build a single 3D printed like jig, you know, case piece that holds the ring light, the modified C920, and like some kind of stiff wire. I could even use part of the endoscope wire actually, because it's a stiff wire with power and USB. So, because I've got too much of that endoscope wire as it is. I could just solder that to the C920 and the ring light. So yeah, something like that that you can pose inside the box is kind of what I want. Right now it's just kind of haphazard. This is like matte black aluminum foil that I'm using as light blocking, and then I have some black tape up here. A lot of cameras, if you disassemble them, you'll find that they're light sensitive on the backside to an undesired degree because they just don't have any shielding because they're usually in a black plastic case. So it was really easy to get light leaks. I put some tape over it. Yeah, I was using this jumper wire to power the ring light. I think we can take that off too. Oh, that's soldered on. That's cool. This is also a little fatigued because as I was maneuvering the microscope around, I kept hitting this wire without realizing it. So then this is also tied down. This is attached with a combination of 3M VHB tape, and I tied it on with wire because I didn't entirely trust the tape, and the ring light would have just fallen directly onto my isopods otherwise, so I tied it on with wire. And then I think the VHB tape will just pull off. This is stuck down a little more than I thought. That's good. I didn't think this was really that strong. Ripped up the foil in some parts, that's fine. So yeah, this is a kind of cheesy ring light. I got this for photography ages ago and used it for that for a while. But I took it apart recently because it was never a great photography ring light, and I think I've got better studio lighting now. And yeah, so inside it's just a bunch of cool white LEDs in parallel. Not much going on there. The other side, which I don't have on me right now, had a boost converter, I think. Actually, it was probably a buck because it would run off of 3 volts. The forward voltage of these is probably close to that, so hard to tell. Probably a little lower actually, so it's probably a current limited buck converter. That might explain why it has such bad battery life. So yeah, but it runs great with like a 10 kilo ohm resistor because it's very dim, but the illumination is nice and broad, and the isopods look especially shiny because this reflects on their shell. So that's pretty great. I like it. Alright, now this, so you can see it's glued around the lens and around here just to kind of keep moisture out. I'm just going to rip off what I can. That actually took most of the glue. The glue did not really stick to the lens holder very well, so that's fine. That's what I wanted anyway. I think now we might want to start bringing out the isopropanol. I want to take off this metal mesh when I can too, because I'm going to hurt myself on it. Should get my trash bucket too. This is my favorite way to get hot glue off. I haven't tried this with 70% isopropanol recently, but I usually have this 99% stuff around, and it works really well. But you can probably use 70% and get a similar effect. It just might be less fast. But as I've said before, it works in a couple different ways. It kind of seems to seep into the glue and weaken it over time, but then it also just relatively quickly gets in between the glue and the surface it's attached to and kind of pops it off if the surfaces are non-porous. It actually could be good to use gloves when I've got this much around. I mean, isopropanol is, I don't know, like solvents in general are not good for your skin and your nervous system and your body. This one is used a lot in medical circumstances, so like you have a lot of skin contact, and I don't know if it's as bad as a lot of other solvents, but with this much, gloves are probably still useful. Oof. these new gloves, and they're way thinner than the last ones I had. Which is, has its upsides and downsides, right? It's like more tactile, but much easier to rip. Oh, these smell like a medical exam room. Does that mean they're powdered? I don't see any powder. What else would that smell be? Is that the nitrile itself? Maybe. It does kind of smell rubbery, not powdery, or not like, you know, like talc or something. What do they use for that? Do they use talc? I wouldn't. Like, didn't they have some problems with like asbestos in the talc supply or something, and that was like maybe getting conflated with talc itself causing cancer? This is sharp. I'm trying not to hurt myself on the sharp wires. So then with this off, I can reuse this lid. I can either, I mean, it would make most sense to reuse it for something that I want ventilation in and just put some screen over this, but if I wanted it to be a solid lid, I could probably just glue a plastic panel over it. Or I could just, you know, throw out this one, but it seems reusable. These bins are pretty inexpensive. I think in quantity they're like a couple dollars for the bin and the lid. Trying not to hurt myself. I didn't actually cut myself, but yeah, this, you just poke your finger through this mesh. It's not that strong. Popsicle stick prototype. Oh, cool. Maybe they do have talc, asbestos in these gloves or something. Yay. That's just what the doctor ordered. I don't see any powder, though. Oh yeah, these are labeled powder-free, so I would assume these are no asbestos. But you never know where you're getting asbestos these days, I guess. What with the government shut down. It's not like anyone else cares. Oh, yes, yes, yes. IPA in a mist bottle. That is also useful. I don't currently have one of those, but I really should. Like, that seems like, I mean, I wouldn't keep a lot of it in there, because, like, I mean, remember this stuff is extremely flammable. Mist bottle of fuel, but, I mean, it is very useful for cleaning surfaces. Okay. That is good enough to set aside, and then maybe do some more cleaning later when I want to reuse this. Fingertips have some nice texture on these gloves. It's cool. So, yeah, put this aside. Now we have this. So yeah, the glue and popsicle stick and metal stuff is just going in the trash, but I want to get the camera module and the wire out of this. It's nice that there's so much ventilation in here. I say as I'm cold. although it hasn't been running the heater a bit, so it's not as cold as it otherwise would be. Some of these sticks are reusable, but most of them aren't, and I have a lot more. I have a bunch of these around. I think I got them for like smoothing out paint and silicone and stuff and stirring stuff. Okay, so you can start to see some of the modification already. Obviously there's I mean maybe not obvious if you're that far away. To me it is obvious that there is a gross glued on lens mount here, which is part of what we're replacing. But there's also this metal plate. On the last stream that we were working on this on, I used some thermal conductive tape to stick this down right there and right there. So the system on chip is under here, the camera sensor's under here, and this acts as a little heat, dispersion thing for, it's like almost a heat sink. It's like a very small heat sink for both of those, but it's way better than nothing. It's pretty necessary. You can also see these are the microphone inputs. These used to be just onboard mics. I added a little length of coax. I had these connected to piezo actuators, piezo transducers as contact microphones. And that actually was kind of interesting. There were some things I liked about that. They did seem like they detected the sort of like rustling noises of stuff moving around nearby. But when I actually put this in the isopod enclosure, there was so much electrical noise nearby that I just couldn't hear anything else. And I think there was just something slightly different about that environment where I was picking up way more USB-flavored electrical interference. Because the shielding was not great on those microphones, the way I had them set up. So I could redo that. There's a lot of room for improvement in that setup. But then I was noticing that this audio input on the system on chip here actually maxes out at 32 kilohertz, which is kind of low quality. So in light of that, because the piezos were just kind of big and annoying, and I wasn't sure if they were bothering my isopods, I took them out, and I just cut the wires right here, leaving some room on here. But I thought about it some more, and I was going to maybe use these inputs for something, but I don't know if there's much I can do with them. I mean, they're 32 kilohertz. I could use them for like data or something that I wanted synchronized with the video, but I just can't imagine that being a good way of doing anything. I feel like the real way of getting data in from my isopods is with like a USB device that talks to some sensors. The real way to get audio in is going to be to have a separate preamp and then use the analog input on the motherboard. So I think I can just desolder these coaxes. I don't think I actually need those, despite all the work I did to put them together. Oh, I was going to put a lens cap on here and I keep forgetting. I'm sure I'm going to need to clean the lens at this point. But I'm also going to try different lenses, so yeah. Whatever. We do that now-ish. Better than nothing. I could be being gentler to this cable. I don't extremely expect I'm going to want to keep it, though. It's an alright cable, but it's also, I don't know. I feel like we could use that stiff wire, maybe. And that would effectively just put the lighting controls elsewhere. I do actually want control of the lighting. Like, I want to try to give the bugs a day-night cycle. I don't know if they care. It doesn't seem like they use light for much. They mostly navigate with chemical senses, and like I haven't seen a lot of research that has that seems to like point toward them having like a strong sense of light being important or good or bad. They generally avoid the light, but that's more because dark spaces tend to be moist and full of tasty things rather than because they really like the dark, or at least it's kind of hard to find research that can really separate those two things. So it's hard to tell. But I want to try different kinds of illumination and find something that, you know, doesn't bother them at all and is also easy to see them with. Right now I'm just using really dim white light, so the camera is always noisy because it's in low light. But I just have this constant dim white light in there. Okay, I'm just taking the hot glue off of these connector areas first. And I might take the coax off. Let's warm up the soldering iron. It's actually kind of relaxing wearing gloves around solvents, because like I don't have to worry about whether they get on my fingers. Okay, let's just throw out this. I don't think I need any of these. It's my little temporary art project. Reckless in Twitch chat says that they've considered using audio signals to synchronize video streams recorded based on separate clocks. Yeah, I mean, that's a common strategy. Like, I think a lot of folks do that, like, during video editing, post-processing. That's certainly how I synchronize my multi-camera recordings. And you can do that either just using the audio that you're already recording, which is what I do. You can, like, synthesize something like a click track or a timecode track. Yeah, I've also thought about like automated methods where you would have some like either pseudo-random or incrementing signal, which you would then, like I was thinking about basically having an OBS plugin for this that takes multi-channel video and uses their audio to dynamically adjust lag compensation on each video stream. Like that seems like it'd be not that hard to do. Like you could look for audio offsets using an autocorrelogram. So you just do a couple of FFTs on every audio block, look for the best match for the offset. A correlogram is this thing that lets you take like two different signals, and it gives you another signal which for every point on the x-axis is an offset between those two different signals. So it's like you're sliding the two signals across each other and looking for where the sum of those like multiplied signals is the highest. And if you do that with one signal against itself, it's autocorrelogram, and that's how you find periodic signals. But if you do it between two different signals, then you're trying to find correlation between them. I think you can do that with an FFT. I forget whether that trick only works for autocorrelograms or not. I would love the microscope available to do this part, but the microscope is in pieces right now. Yeah, actually, I don't know. The thin gloves are growing on me. These are actually much easier to feel dexterous in than the thick gloves. Oops. This would be much nicer if I actually put the board in a vise. Where are my vices? Oh. Where are my vices, she said, while doing all the vices. Ah, I have so many vices at this desk. The little ones and the big ones. A little bit of hot glue in the soldering iron. Not much. I don't know whether, I'm torn about whether to save these little straps of coax. I think I will. Normally I don't save like tiny scraps of wire, but this is not extremely generic wire. This is 0.81mm coax, which is not extremely specialized, but I don't have a huge amount of it. Seems kind of nice. Tempting to short the microphones together, but I think this will just, I mean, either way, I don't think I'm going to use the audio signal, so I don't really care whether it's noisy. Okay. Now some isopropyl both to clean the board and to get the microscope holder off. And this is going to start to become delicate because this is going to expose the sensor, and I'm going to try not to get flux on the sensor, although I might need to clean it anyway. Reckless says they're already at 13 seconds of latency on Twitch. I get curious how the latency compares on different platforms. So if you are also curious, I'd be interested to see whether it is different on YouTube or Twitch or Diode Zone, which are the places that I'm broadcasting right now. I would expect YouTube to be higher latency than the others because YouTube is transcoding, but I mean, I don't know. I think actually the same number of transcodes are happening everywhere. It's just that for YouTube, that same transcode is happening on their end, whereas for me it's happening here with Twitch and Diode Zone. Yeah, my video setup here is kind of complicated, and I'm happy to answer questions about it, but I've also got a GitHub. If you go to scanlime/broadcasting, I have a GitHub page with just notes on how the video setup here is set up and config files and stuff. The short answer is that it's OBS on a Windows machine doing the encoding, and that encodes at 12 megabits using the NVIDIA encoder, which is basically what I consider like editing master quality. It's too big for most broadcasting needs, but it looks really good even if I'm going to recompress it later. So I use that for editing. I save that on disk directly, but then I also stream that to YouTube because YouTube will take anything and recompress it. So I just send it directly to YouTube because they're going to recompress it. Twitch has much lower bandwidth limits. I think they might have increased them lately. For a while it was 3,500 kilobits, which is I think what I'm still compressing Twitch to. So Twitch has a 3,500 kilobit stream, which is the same exact stream I'm sending to Diode Zone. And then, yeah. I could do additional low bit rate transcodes here, I'm just currently not. I thought the bottleneck actually was that there wasn't going to be an open source player that could handle switching between different bit rates, but I think there might actually be one, and I just need to look into it more. Like, I'm using Video.js right now. Ideally, it'd be like a Video.js plugin. I forget what form it actually takes. I just want to be very delicate to this. It's about to come off, but I'm just trying not to hurt any of the board components. there's my spudger. I think I actually loosened that. I heard it kind of come loose a little, creaking a little. This is one of the, I think, 20mm lens holders. The lens holder and lens both came from one of those cheap fisheye cameras. I have the bare sensor board for that one floating around in that box right now. I mean, it's like protected. I didn't just throw it in the box, but I mean, I've got a sensor that needs a lens. It's just not a great sensor, so I could just not, I don't know. I'm sure I can find a use for not a great sensor around here, though. There's a lot of stuff that I could use just like a little camera on. The sensor in this camera is fine, though. It's a good sensor. As I was saying earlier, this camera here is the same as that camera, just a little modified at this point. It comes with an autofocus lens, which I've removed. That's the main modification. But I also attached this heatsink directly to the back, taken off the microphones at this point, mostly because I tried temporarily replacing them with piezos, which was interesting, but not quite good enough to keep. Yeah, that's a topic for maybe a future stream, is making some contact mic preamplifiers and making some leaves that double as auditory sensors, perhaps. I've got this water bath now for keeping their temperature. Oh, I just nicked my glove. Not a big deal for this, but I try to keep an eye out for stuff like that. I should replace this one anyway. Oh, that's a good question. Oh, interesting. Also, I'm sorry I'm a little behind on chat here. Kosumu on YouTube is asking if the isopods hibernate. That's a good question. I don't think they have a seasonal hibernation necessarily, but they do get less active if the temperature is especially cold. So, like they might have something that they do that's kind of to keep alive in extreme environments, but I don't think they hibernate normally. I could be wrong about that. And then Reckless says that maybe Twitch is on normal latency instead of low latency mode. I'll have to look into that. I was pretty sure I had YouTube and Twitch both set to low latency, but maybe that got changed at some point. Yeah, and then there's also a question, which somebody else already answered, but they were wondering if it's okay to use liquids on turned off circuits. And yeah, that really depends on what the liquid is. So in this case, this is